Welcome to my channel RLD Academy. In this video, I'll discuss one gate problem on two-port networks, and this is tutorial number 3. And consider this problem. This problem is taken from gate 2018 ECE, and here we need to find out the parameter B of ABCD matrix for this two-port network. So this T network is given, and for this one you need to find out the B parameter. This problem is very simple one. So we can solve this problem by several methods. So I'll show you 3 different methods by which you can solve it easily. Okay. Now consider this problem, and this one I can solve by this technique using cascading method that I discussed in my lectures. Okay, so I can consider this one as one subnetwork, this is another subnetwork, and this is third one subnetwork. So these 3 networks are connected in cascaded form. Okay, then we can get total T parameters or ABCD parameters for this T network. Okay, and for that we have discussed that if you have a single element network like this, okay, this is your R, this is V1, this is V2, this is your I1, and it is I2, and for that T network is very simple to calculate. Its value is 1, this is 1, and this resistance is R, and this is 0. Okay, and whereas if you have this kind of network, if this is resistance R, this element is V1, this is I1, this is your V2 and I2, then for that T parameter would be very simple to calculate. So this is again 1 1, this reverse voltage gain, reverse current gain remain 1 1, and impedance is 0, and admittance here, transfer admittance, it should be 1 upon R. Okay, so this thing we have discussed several times in my lectures, so please follow the previous lectures if you have some confusion. Now total T, total ABCD, so I write ABCD only, okay, so that I can, so this ABCD matrix, so we can consider these 3 ABCD parameters or ABCD matrix. First one is for this 2 ohm, like this one, so here it will be 2. Okay, so I'll put it here. This is all 1 1, so first I'll put all 1 1, because all are either series resistance or the resistance connected parallelly. So this one, first one is 2, then it is 0, and for second one, here it is 5, like this, so it is 1 upon 5 here. So this is 1 upon 5, and this is 0, and next again it is 2, so 2 will be here, it is 0. Okay, so first I can compute this one, so I'll keep 1 2 0 1 as it is. Then if you combine these two, then 1 1 is 1, the 1 0 0 0 is 0, so 1 plus 0 is 1, then 2 plus 0 is 2, then 1 by 5 plus 0 is 1 by 5, then 2 into 1 by 5 plus 1 means 2 by 5 plus 1 means 7 by 5, right? And then again, now if you consider this product, so this is 1 plus 2 by 5, 7 by 5, Next one is 2 plus 14 by 5. Okay, so 2 plus 14 by 5 means 2 into 2 5 is 10, so 24 by 5. Then this is 1 by 5 and this is 7 by 5. That's all. So this is your B. Your question is, what is your B? This one. Okay, so from here you can conclude that B is 24 upon 5. This is the answer. So it should not take more than 1 minute, right? Okay. Now see the next approach. As you have to find out only one parameter. So from definition only we can find out this parameter. Okay. So from this one, the first equation. Okay. So what is the first equation? V1 equals to A V2 minus BI2. So how to extract the B? So from here B we can write that V1 upon minus I2 if we consider V2 equals to 0. Okay. So if we make V2 equals to 0, then first term will vanish. So B will be V1 upon I minus I2. Okay. So this ratio we need to find out, V1 upon minus I2. With this condition, V2 equals to 0. And V2 0 means short circuit, output side shorted. Okay. So V2 I can make it 0. So this V2 I can make it 0 by short circuit. Then minus I2. If this is your I2, then this side current will be minus I2. So that current I will consider I. So this short circuit current or ISC, rather short circuit current. So this one I can write that it is V1 upon ISC. Right? So how to find? So now it is very simple. So if this is your ISC current, so what is the potential drop across 2 ohm resistance? Okay, I'll redraw the circuit. It will be better. So this is your circuit. This is your V1. This is I1. Okay, I1 is not recorded. I won't use I1, right? So this current is ISC. This is your 2 ohm, 5 ohm, and 2 ohm. I want to relate V1 and ISC. So what is the potential drop across this one? That is your 2 times ISC. Okay. So that potential is again this potential. So this potential also 2 times of ISC. Okay. So what is the current then through this 5 ohm resistance? So it will be, this current will be 2 ISC upon 5, because 5 is the resistance. So voltage across this 5 ohm element is 2 times ISC. So voltage upon resistance is the current. So this current is 2 times ISC upon 5. This current is ISC. So net current. So this current is I plus 2 ISC plus 2 ISC upon 5 equals to 7 ISC upon 5. This is the current. Okay. So now I can take KVL. I can take KVL here. So what is V1? Potential drop across 2 ohm plus this potential drop. Okay. So this potential drop across this 2 ohm is 2 times this current, 7 ISC upon 5, plus this voltage is 2 into ISC. Okay. So can I write KVL? So if I use KVL, so V1 equals to 2 times that current is 7 times ISC by 5 plus the voltage across this 5 ohm distance is 2 times ISC. Okay. So if you simplify, it is 14 ISC, and okay, I can take LCM 5. This is your 10 ISC. Total is 24 ISC short circuit current upon 5. So V1 upon ISC is 24 by 5 ohm, right? So your answer, so this is your B. So this is the answer is matching, correct? So in that way also you can solve it. Now next, I can solve the same problem using the equations only. Okay. Now from here, what you'll get? You'll get two equations. One is V1 equals to A V2 minus BI2 and I1 C V2 minus DI2. So I need to express V1 V2 in terms of V1 I1 in terms of V2 and I2. Okay, from this equation. So this is a T network. This is a T network. For T network, it is very easy to calculate Z parameters or the equation like V1 and V2 in terms of I1 and I2. Okay, that you know, that I have discussed earlier, because this current is I1 plus I2. Okay, so from here, what you will get? The equation V1 equals to, so this 2 plus 7, 2 plus 5 is 7 I1, 7 I1, and middle one is 5, so 5 I2. Okay, again V2 will be similarly 2 plus 5. So this 2 plus 5 is 7, which is I2, and middle one is 5. So this 5 I1 plus 7 I2. Okay. So I need to find out this one, this B. So I have to get this equation. Okay. So from here, what we'll do, we'll find I1. That is V2 minus 7 I2 upon 5. So then from this equation, V1 I'll get the 7 I1, and I1 I can replace V2 minus 7 I2 by 5 plus 5 I2. I need to simplify it. So it is 7 by 5 V2 minus, this is your 49 by 5 I2 plus 5 I2. Okay, so what you will get? It is 7 by 5 V2. If you simplify it, minus, it is 49, 5 is 25 by 5, it is I2. So this is 7 by 5 minus, this is 24 upon 5 I2. It is V2. So you have got the equation V1 equals to 7 by 5 V2 minus 24 upon 5 I2. So this equation we have got, and second one, the coefficient with I2, this is your B, right? This is your B. So B is 24 upon 5. Okay, this unit will be obviously ohm, right? So this is the answer matching. Okay, so in many ways we can solve it. I hope you have got this answer. So if you enjoyed this video, then you can subscribe my channel. It's a free subscription, and to subscribe this channel, you can press the subscription button, and then don't please to forget to press the bell button, because then only you will get immediate notification of my future videos. Okay, I hope you are going to subscribe my channel and keep watching my channels. I'll be uploading lots of videos in this channel. Thank you.